So question 1 in this normal distribution question, we are going to test our hypothesis for a sample. So let's look at the first one. So we are given a hypothesis which H0, the mean is equal to 21, and the alternative is that the mean of the sample is different from 21. So it's two-tailed, and two-tailed, the significance level is 5%. So it's going to be 2.5% on either sides. So let me just draw a normal distribution. The mean is 21. So this variable, the mean is 21. Now the standard deviation is 1.5, but because it's a sample, I'm going to divide it by the square root of n, which is my sample size, because we are looking at a sample. Now the sample statistic is 21.2. So I want to work out this area of this probability. Now the significance level is going to be 2.5% because it's two-tailed. So this is 2.5%, and this would be 0.025, and this area here will be 0.025. Now because 21.2 is on the right-hand side of 21, we want to work out the probability on just one side of these tails. So let's use the following. Now we can use tables or we can use a calculator. If I wanted to use my table, I would have my sample statistic, which is 21.2 minus 21 divided by the standard deviation, and this will give me an appropriate z-score. Now my standard deviation is 1.5 over the square root of 20, and using my calculator, so if I was to enter this in the calculator, 21.2 minus 21, that equals 0.2. And I'm going to divide this, the answer divided by 1.5 divided by the square root of 20, and this is going to give me 0.596. So this is my z-score. Now when we use the z-tables, we need to be aware that the z-table is going to give us our p-value when it's less than. So 0.5, I can go down either column, 0.59. Now the tables is going to be an approximation. So 0.5 is here, 0.59. So my p-value for a z-score of 0.95596 is going to be 0.72240. But because this is for when p is, the z-score is less than 0.596, that is going to cover this portion, which I'm going to shade. But I would like to know the probability of the part that is to my right, because this is where I'm going to test against the significance level of 0.025, which is 2.5%. So now I'm going to take this probability, which is equal to the red shaded region. I'm going to do 1 minus 0.72240, and in my calculator, 1 minus 0.72, 72240, and that will give me 0.2776. Now this is definitely greater than 0.025, so definitely I can keep the H0, and there is not significant evidence to show that there is a difference.